Good morning and welcome to the Adaptive Computing webinar, HPC in the Cloud, Why Adaptive Computing and OCI Win. You'll see how to burst to OCI from on-premise systems and run workloads in the cloud using the HPC Cloud On-Demand Data Center. And you'll see the performance capabilities and benefits that are available only in Oracle Cloud Infrastructure. We have presenting with us Riaan Venter, who's Director of Post-Sales Support at Adaptive Computing. Myself, Sue DeGram, I'm Senior Director of Marketing here at Adaptive. And we have Bennett, who's a Solutions Engineer at Oracle Cloud Infrastructure HPC. I'd like to start out talking a little bit about Adaptive Computing's ownership. Adaptive's been around for over 2 decades. It was acquired about 6 years ago by Art Allen. Art Allen is a unique entrepreneur who is a corporate leader with more than 40 years of strategic experience in the enterprise software industry. He's founded several successful enterprise software companies, has acquired Adaptive Computing within the last 10 years. Most of our customers are commercial enterprises, defense contractors, and universities. We manage some of the world's largest and complex HPC computing installations in the world. Right now, we are managing over 3 million on-premise cores worldwide at 150 plus customer sites. These are some of our customers here below. During this presentation today, we're going to be talking about the HPC Cloud On-Demand Data Center. The On-Demand Data Center is an extremely flexible and scalable cloud management solution used for automating infrastructure deployment, monitoring, scaling, and shutdown of cloud resources. Okay, I'm going to let Riaan take over now and talk a little bit more about the HPC Cloud On-Demand Data Center.
As we go along and there are any questions from anybody, please go ahead and post them on the chat. We'll keep our eye on those, but we can, Sue will kind of let myself and Brian know if there are any specific questions we need to look after as we go along. Otherwise, right at the end, then we'll review any questions and then we'll answer all of those for you guys. Now, talking more specifically about HPC Cloud On-Demand Data Center, if you look at some of the key points in the sense of, when you're talking about HPC and what kind of, environments that require a solution like On-Demand Data Center, and we're talking about hybrid cloud, for example. That's a very common, requirement that people talk about. If I want to, I've got an on-premise environment, but I'm looking at extending that on-premise environment. And this is where we start talking about, cloud move or extending that environment of your on-premise into the cloud. Or we could actually set it up that you run completely in the cloud, or you, based on, let's say, backlogs and so forth, extend those resources in the cloud. And things like cluster resizing, you'll notice that when we go through the demonstration, you've got the options of, well, let's resize my cluster, maybe a little bit smaller, maybe a little bit bigger. Some of the key areas that we've started building in over time, and they're available by default, is for example, container support. When we're talking about Docker Singularity, Kubernetes is also available, being a resource manager for Singularity and Docker. And then we've already by default built in parallel file systems. For example, NFS, BGFS, they are already available. And we've got something called data anywhere. So it's really a term that we use that explains how we manage data, because we know that question does come up quite often. We'll go through that as we go along. And then also, when looking at our demonstration environment, we're going to use Moab, which is our scheduler, but it doesn't have to be our scheduler, or you don't need to use a scheduler. You can run it directly in the cloud, as we call it, pure cloud. And then, if there's a requirement for another scheduler, we interface that within our on-demand data center. And you would notice that it is very purposefully built to make it easy for end users. So they don't need to know anything about the cloud or change the way that they're working. It is keeping that same experience for people that still want to run, command line environment, or if you want to run certain things, within pure cloud, meaning I don't want to worry about on-premise, I just want to run in the cloud, and I'll show that to you. And one of the key areas that I'll definitely be talking about is, we call it cloud bursting, which is all automated, and it will definitely have a 50 to 70% cost saving from that point of view. Now, looking at some of the use cases, we have, as I mentioned, the hybrid IT, where you've got, keep some workload on-premise, move others into the cloud, meaning extending that on-premise environment. And nowadays, organizations look at, well, I've got this hardware on-premise. Do I need to kind of renew that or revamp that or add to it? You don't need to do that. You can actually go ahead and make use of your cloud or your cloud service providers. For example, a GPU, right? A GPU, as you know, is very expensive, so you don't need to go and buy a new one. You've got access to that within the cloud environment. So rather than acquiring that, going additional cost or adding additional cost to your budget, you use that in the cloud. And using on-demand data bursting functionality, you only use it when required. So it doesn't mean you have to use it 24/7. And of course, we know in the HPC world, people do require, high performance kind of types of devices, in the sense of, again, GPUs and specific types of resources that you must be able to run, rendering simulations. I like to use an example of when you've got, for example, a room full of developers that are, running, testing their code, doing pipelines, and they do make use of cloud resources. So from that point of view, at the end of the day, they knock off, they've got resources on the cloud, they come back the next morning, and that resource that they've been using was still running until the next morning, so you keep on paying for that. So by using on-demand data centers, bursting, as well as automation functionality, after they knock off, you can set it that, okay, there's no more workload, let's bring those resources down, and only when you start working the next day and require more resources, and that's when we start them up again. Now, taking all of that into consideration, this is kind of just a overview of, let's call it, how it works. So it's an approach in the sense of, if you look at the left-hand side, how we look at from an on-premise environment. So we've got our job scheduler. In this case, I'm going to use Moab, but as I mentioned, it could be another scheduler that we interface with on-demand data center. And then we've got something called Moab on ODDC Connect, On-Demand Data Center Connect, which is the interface that we've already built from a Moab point of view. And that assists with bidirectional communication from on-premise and into my cloud environment. So that will assist you moving that workload. And you'll notice that as we go through the on-demand data center environment, where there's a few steps that we follow, very straightforward, to actually get a resource within the cloud. And I'm not going to talk too much about it right here, but it just shows that interface from a technical approach point of view, setting this up, it's very straightforward, easy, 2 environments that needs to be installed, and we assist you by setting up your environment within on-demand data center, meaning a stack, obviously credentials, and defining a cluster and deploying that within your cloud environment. And you'll notice that I've got Oracle Cloud in there, and we've got our Oracle colleague today with us, that we've got a close relationship with them in that sense. But we do cover all service providers from one area. Now, as I mentioned, this is where we talk about bringing everything together in one place, a single pane of glass. So we're talking about multi-cloud cluster orchestration. You'll notice on the right-hand side that we do manage all service providers from within on-demand data center. And this is a kind of small, but you'll notice in the demonstration that you can set up cloud resources from all the different providers, all from one single place. Now, as I mentioned, the steps are very straightforward. I mean, first of all, obviously you need a credential, a cloud provider credential that you are allowed to deploy resources in the cloud. So that you need to have. We can assist you with that, or the cloud provider can assist you with that. The next step is, as we call it, a base stack building of an image within your service provider. Now, this is important in the sense that this is the time when you can start including some of your own applications that we may not have available within our default image. Within our default image, we already have a set of base software that is included. And, for example, we've started including things like MPI, OpenFOAM, and, certain other applications like VPN. We've included, your file systems like NFS and BGFS. When you run your default base stack by default and don't add any application, all of those are already available. Then you can decide, okay, I want to add another application. So we can work with you and we'll create that application, script that you include. And as soon as this image is created, now remember, this image gets created within your service provider. Next step is to configure your cluster. So you set it up, you decide which provider, which region, how many nodes, how big your nodes are. And as soon as you've configured your cluster, it's as simple as, deploy. That's it. Straightforward, very simple. And I'll show that to you as well in the demonstration environment. Now, I was talking about cloud bursting. So that's a very key and important area in the sense that this is where you're going to start having huge cost savings. Now, we do have customers that prefer using fixed or persistent clusters. For example, if they've got an interactive application, you could do that, but the bursting options make more sense because you're not going to keep those resources up and running all the time, only when workload comes in. Now, we've got different options within bursting. For example, maximum bursting means, depending on how many workload comes in, and you've got a cluster that's got, let's say, 20 nodes, you've got 10 jobs coming in, each one requiring one node, one core. What it asks for is give me maximum available resources to get this workload done as quick as possible. So max means just get things done as quick as possible. Minimum is we're going to run your workload sequentially, meaning one after another. So it will get your workload done, but it will take a little bit longer, and that's where you add a further cost saving on top of the bursting functionality itself. And then we've added something called all, which is it's an option of irrespective of what's in the queue and the job queue, irrespective of what is available from a cluster point of view, just start up everything and let's get things done. And then we've got additional options that as we talk about on-demand features where you could a single user could say, well, okay, I just want to quickly run one job without having a cluster defined. And if he chooses this option, he can actually define his cluster, let it deploy. It will take care of that workload, and we'll bring it down. And then there's different options when you start resizing as well. For example, you can resize a persistent cluster at any time. If you want to resize a bursting cluster, you just need to switch off bursting, and then you can resize your cluster. Right. So, and this is kind of just bringing that all together, right? So we're talking about the different bursting options, minimum, maximum, and burst all. You can have a persistent cluster and the on-demand options. As I mentioned, within on-demand, there's different options that, even though the default option is if I complete my workload, let's bring down the whole cluster, but you can tell it, all right, let's keep my head node up, take the nodes down, or put them into bursting as well. So there's different extended options within the on-demand environment as well. Now, important area over here is to note that on the top right, it says pattern number. That is our CEO received, awarded the patent on bursting. I believe it was towards the end of last year. So we actually own bursting functionality as adaptive computing. So that's quite important for us. Now, this is kind of using what we've already spoken about, but extending it even further. Now, you'll notice, to go through this diagram briefly, you'll notice is, we're talking about an on-demand data center in a grid format. Now, within our scheduler, Moab, its default functionality called Moab Grid. So, for example, you've got, let's call it a headquarters, and then you've got all your different data centers that could be residing within, different states, regions, countries, and now you can use the grid functionality to have your master manage all of these data centers, right? So you configure your grid environment with a Moab installation on your, let's call it your master, and then within each one of these data centers, you also have an installation of your scheduler. Now, any workload that comes in your master, you could actually migrate that to your data center. Now, we're talking about on-premise, right? So let's say my on-premise master is filled up, I can extend that into the cloud. And if that's also fully utilized, then I can start migrating all my workload down to my data centers, or I can tell it by default, I want to migrate all my workload to, let's call it decentralize all my workload. Now, within these environments, you can have users submitting workload directly within your master on your, let's call it your headquarters, but you could also have users submitting workload within your data centers. And then we extend it even further by my data center, for example, if that on-premise resources get filled up, I extend it even further into the cloud. And this setup is, I've done it recently, set it up, it's out of the box, and we've had quite a few, requirements for these lately, especially bigger organizations that have got multiple data centers that they need to kind of take care of. And it could be obviously split down in, your organization may have different departments in different areas or regions with each one of its own data centers. So that's another way of actually doing it. Now, at this stage, I'm going to hand over to my colleague Brian from OCI so that he actually goes through his side for us. So,
all right. So this is just our safe harbor statement that I want to leave up here for a few seconds for everyone to read before I begin presenting. Okay. So Oracle Cloud, or OCI, is available globally from more than 30 plus cloud regions, and Oracle is rapidly building more, new regions. This is here to show that even though we're a US-based company, we're committed to a global reach, so your workloads can run where desired. Our goal is to offer strategic location proximity and meet data sovereignty requirements, as well as provide true disaster protection with multiple geographically distributed cloud regions in every country. OCI serves commercial businesses, the US and UK government, and the US Department of Defense with distinct regions that must meet specific compliance and tenancy requirements. We also have unique hybrid cloud options, including the dedicated region cloud at customer, which offers all OCI services, on customer premises. This range of options provides customer access to cloud services, current and future, with the same SLAs for availability, performance, and management, as well as consistent APIs for simplified management. We offer a range of isolation offerings that can be applied to multitudes of customer use case and deployment requirements. We are also uniquely positioned to bring the cloud to you with a dedicated cloud at customer offering should you need to meet specific regulations that would prohibit you from utilizing a multi-tenant public cloud model. To take advantage of our GovCloud, you don't need to be a government entity in order to utilize it. As a commercial business with government organization clients, or patrons, you can take advantage of our GovCloud regions to provide services. The pricing is also consistent with what you would pay when using our commercial regions. We don't charge a premium for, added government compliance. Also, pricing amongst all of our data centers are consistent. We don't charge a premium for using data centers such as, Brazil or Tokyo. Not only are we bringing government compliance to OCI, but regional compliances such as GDPR and C5 and industry compliance such as HIPAA and PCI DSS. We're constantly adding to our repertoire of compliance and certifications so that way you can run with confidence your workloads in Oracle Cloud. So now that we've covered compliance and certification at a high level, let's look at what OCI can bring to you as a customer. OCI offers complete cloud capabilities available in commercial regions, government regions, and on-premises, right? Not only do we offer infrastructure as a service or IaaS, we also have platform and software as a service as well. We're bringing a complete cloud offering, so you don't only have to move bits and pieces of your business operations to the cloud, but should you want to, you can move all of them in their entirety. So why do we find ourselves uniquely positioned or different from other clouds, right? Why are we calling ourselves a Gen 2 cloud? Well, we realized that we needed to take a very different approach with the construction of OCI, and that's because of our heritage with the types of enterprise applications that are the hardest to move to public cloud. Rather than rewriting all the applications in the enterprise, we built a cloud that would bring cloud scale and consumption models to every cloud application or every application. We built our core infrastructure services using off-box virtualization to create non-blocking networks that could support L2 network virtualization to natively support, VMware and other clustering architectures. In the HPC space specifically, we implemented RDMA networking and bare metal shapes to provide customers with superior cloud performance comparable to other on-premises performance. And, this is backed up with performance, accessibility, and management SLAs to bring, a true Gen 2 cloud to customers. So let's go over some of our components. Right, Oracle has a long history of acquiring companies to produce the best quality and high-performing hardware for hosting enterprise applications. In 1994, we purchased the RDB division of Digital Equipment Corporation to run our database products on high-performing VAX and VMS mini-computers. In 2010, we purchased Sun Microsystems, and as part of that acquisition, we got access to some of the best hardware for high-performance computing with Mellanox cards and InfiniBand technology. In 2016, we launched our first bare metal offering on the cloud and then expanded this offering to include a specialty HPC shape with Intel X7 processors and GPU shapes with Pascal and Volta NVIDIA GPUs. And our offerings continue well into this new decade as we have released our new generation HPC shape with Intel X9 processors, our E4 shapes with AMD Milan processors, and our third generation GPU shape with NVIDIA Ampere chipsets. We're also working with partners like Adaptive Computing to make sure that our customers can easily deploy and utilize our innovations and offerings such as flexible shapes and instances. OCI provides a better HPC platform than any other cloud because we offer true bare metal. Other cloud providers may market bare metal. However, there's often some sort of hypervisor overhead, or it's not a single tenant offering, meaning it's not dedicated to you. We offer true bare metal without the hypervisor layer, without any Oracle software inside. We provide just the infrastructure so you can connect to it and configure it as you would an on-premises server. In our cloud, we believe we provide a better price to performance than other cloud providers, and we have benchmarking data to back this up, particularly for our HPC shape. We have shown that we can match or surpass the performance of on-premises environments. We have done many customer proof of concept tests that show that we are more efficient than their on-premise environments. And this is using a wide variety of simulation software from CFD to molecular modeling to crash modeling. For storage, we're offering 6.4 terabytes of local NVMe storage. And for customers that require or need additional storage, we offer elastic block volumes that can provide up to 32 terabytes each at up to 300,000 IOPS per volume. Lastly, we have shown that parallel file systems have higher throughput on OCI than other cloud providers, and this includes commonly used file systems such as IBM Spectrum Scale, Lustre, GlusterFS, BGFS, and others. OCI provides a specialized network that's not oversubscribed, so you won't be getting a lot of noisy neighbors affecting your performance. It's also a rather flat network with 25 gigabit per second bandwidth, and it's the only cloud network with a network performance SLA. We guarantee that your resource performance should be greater than 90% of the published performance 99% of the time. We set this up so that no node on our network is more than 2 hops away from another. And lastly, we provide a 100 gigabit per second RDMA network to run tightly coupled workloads across clusters of HPC nodes. This RDMA network is high bandwidth with ultra low latency that can go as low as 1.5 microseconds, which we'll talk about a little bit more on the next slide. So when we're looking at RDMA cluster networking, this is the type of networking that you need for the highest level of performance for data systems and performance-hungry HPC workloads, such as, the CFDs, the crash simulations, reservoir modeling, DNA sequencings of the world, right? It's particularly useful for running tightly coupled workloads which divide and distribute jobs amongst clusters of nodes for efficient processing. Currently, we're offering RDMA networking for our HPC BM shape and RDMA for our GPU shape. In this configuration, servers are connected directly to the RDMA switch. There's no hypervisor, no virtualization, and no jitter, right? Typically in other clouds, data has to go through a VM and a hypervisor before it can access the underlying server hardware, and VMs can be distributed across the entire data center. This can add significant latency and unpredictability in performance. With our RDMA network, this allows customers to configure compute nodes onto the low latency network, and each node is connected in a way that simulates a hardwired connection. So these are some of the instance types, right, that we're offering within our cloud for HPC workloads. We have AMD EPYC standard instances, Skylake processor instances, our Intel X9 instances, bare metal GPU instances, ARM instances. Ultimately, what we're trying to showcase here is we're committed to our bare metal cloud strategy, and we're taking stride in making sure that when we launch new instance types, that there is a bare metal offering. Right, we want to make sure that there's a good selection of choice when it comes to running workloads on OCI, whether virtualized or bare metal. We offer a wide variety of storage and parallel file systems. I've mentioned before that we offer HPC bare metal instances that include 6.4 terabytes of NVMe flash with extreme low latency storage. We also offer high performance all flash block shared storage with adjustable performance levels, all the way up to ultra high performance at around 300 IOPS per volume. And then there are also critical parallel file systems built on high performance bare metal instances that can easily achieve over 60 to 140 gigabit per second throughput while, offering customers the choice of choosing from different file system types such as Spectrum Scale, BGFS, Lustre. This is here to showcase, performance, right? There's nothing more performance than looking at a car go really, really fast, right? Red Bull Racing Honda leverages machine learning and data analytics on OCI, and it's optimized and organized in a way that allows them to use it, throughout all aspects of their business, from on-track activities to putting more information in the hands of the team's global fan base. Aleph Alpha, does large model training on a multitude of GPUs that we have within the OCI. When we look at Altair, right, HyperWorks Unlimited Virtual Appliance is a fully managed engineering service that provides modeling and visualization software. All that runs on OCI. And then, lastly, we have Zoom, right, where they're actually able to, transfer 7 petabytes right through Oracle Cloud infrastructure each day. These customer references are here to show the scale at which you could potentially be operating within an OCI, right? You know, we've been around for a long time. We understand how to run large workloads. We understand how to get the most performance out of workloads, and we're here to help you. With that being said, I'll turn it back over to Riaan.
Right, great. Thank you very much again. Thank you very much, Brian. Yeah, so, you know, we do work very closely with the OCI team, and, you know, myself and Brian and the technical guys work close together, having a you know, close relationship, and that's why we also, you know, on a regular basis when we talk to customers, we do recommend OCI due to all those reasons that Brian has mentioned. Now, what I'm going to do is, this is just quickly to show what I'm going to do from a demonstration point of view. So I'll be using our on-demand data center user interface, as well as our scheduler, MOAB, the command line side of it, where I'll go through the kind of, let's call it the script that's going to run a certain amount of workload, and then kind of simulating where we fill up a on-premise environment and move that data from on-premise into the cloud, and using a bursting cluster to deploy those resources, run the workload, and then, you know, we can review some of the specific areas within the on-demand data center environment. So I'm going to jump over to my live environment over here. So let me go into my user interface environment. So right over here, you'll notice this is, you know, the login screen for our on-demand data center user interface. Now, I think it's important to mention that what you see over here, you do get within the command line environments. Exactly the same, everything available that you can do from here. So I'm going to log in as a administrator. Now, you know, those kind of questions do come up that, okay, so well, who could be users, who could be admins, and that's your choice. But it is important to keep in mind that an administrator would be the person that could do all the things that we've spoken about, meaning, you know, setting up credentials, creating a stack, or building a stack, and creating clusters and setting them up. Obviously, you could give access to users that just use them. So that's important to keep in mind. Now, this is the landing page when you log in. So this is, in one of my slides, I've shown that we're talking about, you know, a single pane of glass, where you could notice in this screen over here, I've already got multiple clusters running here, different providers. I mean, there's one for OCI, Amazon, Google, a few more for OCI, another one for Azure, and different sizes. All of my clusters in this case have got bursting switched on. So before going through more detail into this, I am going to use this one specific cluster that is currently deployed on Oracle. So in this case, this cluster is actually deployed on in Virginia, in the Ashburn data center. So you'll notice that there's currently nothing in the queue. So I've run some workload before. There's nothing in the queue waiting for workload. Currently my nodes are down. Remember, my cluster is actually in bursting state, meaning my head node is up and my compute nodes are actually down, waiting for workloads. Remember, it's all automated, so you're not going to have resources up all the time, because that's exactly where the cost saving is actually coming from. Looking at this specific configuration, as I mentioned, you'll notice the bursting service on. I've got it on my maximum burst option, meaning get things done as quick as possible. And this is just a small cluster that I kind of configured from 3 different types of nodes. One has got 4 cores, 8 cores, 16 cores, one of each. So that's my cluster configuration in this case. Right, so I'm going to jump back to my environment, where I'll show you running from the on-prem environment workload, and then we submit it to my cloud environment now. And then we'll go through a few of these options over here. Right, so I'm going to jump to my MOAB environment. So this is my MOAB command line environment. So if I do a command called choke queue, which is a MOAB command, it just shows me currently what is running. There's nothing in the queue, nothing active, nothing waiting. And then just to show you what my environment looks like, there's a command called indiac -n, which actually shows me my current environment. So from on-premise. So this is my on-prem node that's got 16 cores. And then I've got, you'll notice these are actually my cloud resources. So remember, I mentioned that on-demand data center connect we install within my on-premise environment that as soon as you've got it configured, it knows that these resources are available. And remember, my 3 nodes were actually down, right? So they're actually down, although Moab, as a scheduler, knows that they're actually available, showing them as idle, right? So it's actually resources that's available. Right, so just to start the process, and then we can talk through that, I'm just going to show you the script that I'm going to run, and that's just simulating kind of multiple types of workload that's going to run. So first of all, I'm going to run one job that just runs on-premise. It requires 4 processes just to start the process. And then I've got 4 more that's going to kick off, these 4 over here. And you'll notice that there's the dependencies, and that's just being a scheduler. So these 4 are dependent on this one to complete. And when these ones kick off, oh, by the way, this one runs 60 seconds. These ones run for 1 hour. And each one of them require 4 cores. So that is my 16 available cores, as I mentioned, on my on-premise environment. And then my full on-premise environment are fully utilized. And then I've got 20 users that actually goes and submits more workload, right? So each one of these users is going to submit one job that's going to run for 5 minutes, and it's going to require cloud resources. And then we're going to start moving that workload into the cloud. So I'm going to go ahead and kick this off, and so that we can see that the process starts. Now, in the initial stages, as you can see, this is just the on-premise scheduler taking care of workload coming in, right? So remember I mentioned that we're simulating this environment where I've got, certain on-premise workload that's happening. And you'll notice that the first job that started, and this is still running on-premise, nothing in the cloud yet. So it's just starting the process. I've got this job that runs for 60 seconds, and it's going to, as soon as this one completes, my next 4 are all dependent on this one to complete. So then these 4 will kick in, go into the active job state, or queue at least, and it will actually fill up my 16 available on-premise cores on my on-prem node. And then you'll notice that my 20 users have each one submitted one job, each one requiring cloud resources. In this case, mine requires 1 node, 1 core. And so then my scheduler needs to start taking care of these, right? So it needs to say, well, okay, what should I do with these? And remember, as I mentioned, from let's call it an installation point of view, over here we've got my scheduler environment installed. And remember, Moab as a scheduler, it's our legacy products. There's a lot of pieces behind it. It's very rich. It's come from many years back. And then, we install On-Demand Data Center Connect. That's the interface between on-premise and the cloud within this environment. And after configuring it, which is very straightforward, telling it where the cloud environment is, which cluster, which user, and so forth. Now you'll notice my user jobs are already moving over. So my 4 started on-premise are utilized, and now all my user jobs are being moved also into the active queue. And as you know, as I've seen, 16 cores used, so where is it actually going to? It's being moved into the cloud. So I'm going to jump back to my cloud environment, my on-demand data center. So you'll notice, remember there was nothing in the queue. So now we're building up this queue of mine. And remember, the reason for it being queued is this cluster is in a bursting state, meaning only my head node is up and my compute nodes are actually down. And each one of these jobs require 1 node, 1 core. So you'll notice that, right, so my nodes were down before, and now we're already starting to deploy a certain amount of nodes to take care of that workload. Now, we've got something called a burst cycle that mine is set to 60 seconds. So every 60 seconds, On-Demand Data Center checks my queue over here. And there, by the way, all my 20 jobs have arrived. So that's all the way from on-prem into the cloud. And now we actually deploying my compute nodes. Now I've checked and say, so it depends on what's in the queue at the time and what my actual jobs require, right? So these jobs could have asked for maybe, 5 or 10 cores, maybe 2 nodes. We got some applications that do inter-node communications, for example, MPI. So then you would say, right, I want 2 nodes, and it will actually split up 1 job between the 2 nodes. And that's how MPI actually works. It's just one of those types of applications. And now we are busy deploying those. And so the process that we follow is initially they were down, and now we're busy deploying my nodes. And it takes about 3 to 5 minutes, depending. From provider, it's very close, similar, but it does take a few minutes for my compute nodes to deploy within my service provider. And now, as soon as they are available, we'll move them in available state, and it will be allocated against my queue, and then they'll become busy, right? So then we start running my workload, and then the opposite happens, right? So, and remember, I didn't do anything with this. It's all set up front. It's all automated. So when my workload comes in, we take care of this workload. We deploy the node. We take care of the workload. And as soon as it's done, we start bringing them down based on, we've got something called the idle purge, meaning how long should I keep my node up within in the cloud environment, within the service provider. Mine is set to 2 minutes. So there's no more workload. Then we start bringing them offline and we start destroying them again. And it waits for the next workload to come in. So it's all automated. You can sit back, you can watch it, and it's actually doing everything for you. Now, just going through a few of these areas, remember in the beginning I mentioned about, first of all, you have to have credentials, right? So you have to set up credential, simple, straightforward. You select a service provider where you get your credentials from. So it's a question of uploading it or typing it in over here, and then you've got your credentials set. And this will determine or give you authorization to be able to deploy certain types of resources. Then the next step was a stack build. So you don't always have to run a stack build, right? So you may have a colleague that already ran a stack build and you just use that existing image. The process is again the same. You have to have a credential to be able to do that because you are creating an image within a service provider. Now, give it a name. This is important, the prefix part. That's what my image is going to be called within my service provider. So that image, it gets a name. So if you want to add application and call it that application's name, absolutely. Because at this stage, you can actually add, as we call it, a server provisioner or a node provisioner, meaning a specific application, and you can include it within your stack build. I normally say this is the better time to do it because now you create an image that is always available in your service provider, and when you can deploy and destroy clusters, that image always remains available. So that application remains within that image. And it's a question of setting up, and there's a few things, the same as your cluster configuration. You have to select your credential. You have to use a head node size to be able to build your cluster. And then you decide on the region. Each provider has got different data centers. Each one has got different requirements. Some have got availability zones, hub networks, others don't ask for it. It depends on which provider it is. And you run your build, and this typical build kind of runs for around about, I would say, anything from 20 minutes to 45 minutes, depending on how much or how big your application is that you need to include. Our default stack most probably takes about 20 minutes. And then you get to then you've done that part. You've got your image, you've got your credentials. Now you can go ahead and actually start setting up your cluster. Same process. And that's why I mentioned it's very simple, straightforward to set up. We made it very easy for end users. Again, you have to give it a name. So just call it, I don't know, test cluster or something. 20 something. And then obviously the operating system at this stage by default is CentOS 7. And remember, this is the core that I mentioned, the prefix. So whatever you built your image for, that's the name that you're going to use, and you can change this based on each cluster. And you have to have a credential, head node size, so you can choose. And by the way, this list, you'll notice, is fairly small. We give the option to the customer to define this list because this is determined by your credential, what you are allowed to actually deploy within your service provider. So I can just choose one of these as a head node. Typically, a head node doesn't have to be that big. You can choose between Talk and Slurm. We've already got available as a resource manager. Talk coming with MoApp. And then you decide on your region, as well as I mentioned, you have to choose a availability zone. And then there's other options here. I'm not going to go through those in too much detail, but this one is an important one because that's when you use bursting, right? So when your workload is done, how long should I keep up all my, my nodes before I start bringing them down, right? So this is where you decide that. and then you can over here by default it is NFS as a file share system, or you can use VGFS. I've already included that, or you could use yours. And remember, we spoke about data anywhere in the beginning. That's important because that's really what it says. It's a term that we use, that data could reside anywhere. So you could use by using scripting within your job environment, access your data or input data and write your output data either from on-premise into the cloud, or write it back into the cloud or to another file system somewhere. It's really up to you where your requirement is. We'll build it with you and set it up that way. You can choose your bursting at this stage. I normally do that afterwards. So I first deploy and then I switch on bursting. And over here I can start choosing a compute node. Just keep note of this little figure over here. You'll notice that after choosing a head node size and a region, that started counting. So that's just giving you an estimate. It's not exact. We know, customers do have, discounts and so forth from providers, but it's important to keep in mind before you deploy your cluster, what you potentially would be paying per hour for this cluster that's consisting of a head node and a set of, compute nodes. Now, again, Brian spoke about, from a OCI point of view, you could have bare metals. I could add maybe 2 of those. You'll start notice that climbing. Also, maybe a GPU over here. And as you know, GPUs are traditionally expensive. So I can add that. So now it's jumping to $9.35 per hour. So this shows you how I can build that. And then it's a question of you saving this. And it's really, as I mentioned, if you look at right here at the bottom, this is why I've just created this one as a question of selecting it and saying deploy. And we'll go ahead and deploy this cluster on this size with these kind of nodes that it will actually deploy within that region that I chose. So it's very straightforward, easy to do, and same thing if you want to destroy it. Now let's have a quick look at what my workload has been doing. Remember, we had some workload in there. I'm sure some of them are actually running by now. Oh, actually, it's already taken care of all my nodes. Now, all my workload, right? So it's used them, it's run my workload, and now they're available. So remember, there's this process of now, after 2 minutes, these will actually be taken offline, and then they'll actually be destroyed. So my workload that was in here has already been run. You'll notice that's actually our time right now when this was run, and as soon as my 2 minutes goes over, these will be destroyed automatically. And if we want to have a look at the output file, we do keep the standard output and standard errors within the on-demand data center environment. So I've got the option to look at a specific cluster. I was working on this one, so it will actually go and fetch my files that just ran, right? You'll notice the time that I ran them. These came from my on-premise scheduler, and it's a question of viewing it from here. And remember, this output also gets written back to my on-prem user that submitted the workload. Also important is, remember, we talk about pure cloud, meaning you can run directly from here. If you don't want to run anything from the on-premise environment, you can set up workload from here. So as simple as selecting and defining a job for yourself, giving it a name, how many nodes, how many cores, adding a script within here, adding data files. I'll use the example over here. This is actually was one that I created for somebody that, they were saying, well, okay, I want to use my input data from on-premise, but I want to run my job in the cloud. So I said, absolutely. So run it within ODC. And actually what this does, it actually does a VPN connection to my on-premise environment from my cloud, and it mounts a share NFS where my input data is. I use the input data, I write that output data to that same share, and then I unmount my share and I disconnect my VPN, and my job is completed. So it's just as an example. So as I say, over here you can actually define your jobs, and it's very easy. There's 2 ways you can do a submit from here, and you select the cluster that's if I say I want 2 nodes and 20 cores, and my cluster doesn't have that, it won't show it up here. So it shows me what I can actually run it on. Another way is there's a little suitcase over here that you can say, all right, I want to select one of these jobs of mine, and you can run that against a specific cluster. I suppose as a final kind of input over here is you looked at that costing, right? So over here you'll notice that from each provider we keep based on what is currently set for this environment from this ODC installation, each one of their regions, what these different types of devices, what the cost would be. So we get that information from the provider, and then we make something called a accounting option available, because remember, we keep all this data within on the One Data Center. So you can actually go and view information about all these different jobs that actually ran, which nodes they used, what the cost for each one of them are, and so forth. So a lot of information available in that environment. And then I want to finish off by just showing you the cluster itself that we looked at, that actually now we can have a look at what's been happening. Now you'll notice that it's actually being destroyed. So my workload has been taken care of, and now automatically bringing that nodes down. And as I mentioned, maybe as this is a final step, just to say, you know, when we're looking at users, meaning I'm an administrator in this case, you can, as administrator, you can define a new user, and as you create your user, you can decide what that user should be, right? So this is a normal user. I can go and edit this one and decide whether it's an admin or a normal user. And obviously over here, this is where I mentioned about, you know, your bursting service, check every 60 seconds on my job queue, and how long do I want to keep my you know, input or data within my database, so that I can generate additional accounting information or even pull reports from that. So I'm going to end off at this stage and then open it up if there are any specific questions. So Sue, I'm gonna stop sharing over here, and then if there are any questions, we can have a look at that.
Okay, I guess with that, we'll conclude our webinar for today. If you'd like to contact us, please email us at info@adaptivecomputing.com or call us at 1-239-330-6093, or visit our website at www.adaptivecomputing.com. So once again, thanks for joining, and have a great day.
What I'm going to do is, you'll notice that I'm currently now on my login screen for the user interface. So I'm just going to briefly log in here, and then I'll go and start a workload. So what I'm doing over here is I'm actually logging in as an administrator. Just keep note of that in the meantime. And this is my landing page of the user interface. Now, I'll talk a little bit more about all these different options over here, but I just want to start the process first. And over here, you'll notice I've got 2 clusters defined, both in Oracle. So let's just have one of these. I'll actually run my workload towards this specific cluster. I just want to show you that, you know, there's currently nothing in the queue. There's been workload that I ran, but it's nothing queued, nothing running. And you'll notice my compute nodes are actually down, right? So remember I spoke about bursting. So that means my head node are actually up and my compute nodes are down because of the bursting option that I chose. So I chose a maximum bursting, meaning as workload comes in, gives me a maximum available based on that cluster. And you'll notice on the right-hand side over here, this is my configuration of my cluster that I've got 3 different types of instances over here. These are fairly straightforward, you know, VMs. Each one has got different amounts of cores. So you can build up your cluster to have any kind of device, right? A GPU, a bare metal, all these types of VMs based on what you need and require for in the cloud. So this is set up, available. So before we come back to this, let me jump to my, let's call it my on-premise command line environment. Now, what you see over here is I'm logged into my Moab environment. And again, this is running on our data center, and as well as my on-demand data center is also running against Moab's also running here. Now, just a quick command to show, this is, people may be familiar with this, typical scheduling kind of commands, you know, most schedulers do it the same way. Over here you can see that there's nothing in the queue right now. And then I just want to show you what is actually currently on-premise, where we can see to show you this. Now over here, this first one over here is my on-premise resources available. So that's, I've got 16 cores. Now these extra few over here, the next 4, you don't have to worry about those. Those are, as we call it, migrate. So it's a functionality that you can actually migrate your workload to other instances of your scheduler, right? So it could be next door, it could be in another building in another country. So it's just assisting to, kind of spread out your workload even further. Then you'll notice these 4 nodes there at the bottom. Now, my first cluster I just shown you, that's the first 3 of them in here, and then the last one is the second cluster. Now, that shows me that my on-premise environment is aware of my resources, and you'll notice they're in an idle state. So even though they're actually down, it means they're still available because my scheduler knows I can actually pass on workload to that. All right, so let me just show you my script I'm going to run. So what this is going to do is, and again, it's one command. You'll notice that I'll be kicking off one job, and in this case, I'm just using simple sleep jobs as part of the, showing how it works. It could be application specific. This first job will run, and will run 60 seconds using 4 processes. And being a scheduler, you'll notice the next 4, and these are the next 4, each one requiring 4 cores, and that will come up to 16, meaning my full on-premise environment is utilized. And you'll notice the depend. So it's just being a scheduler, these 4 are dependent on that one to complete. And then immediately after these 4, or as soon as it goes into a running state, I've got 20 users submitting each one a job, right? So that's going to be 20 different jobs from 20 different users. So let me kick this off. And as I mentioned, this is one command, and from here on, I don't need to do anything, right? Everything is set up, it's configured, it's available, and right now what you see over here is my on-premise scheduler taking care of my workload that came in. And you'll notice that my first job it's in the active jobs queue, is running, and as I mentioned, this is going to be running for 60 seconds, and then you'll notice in my queue that's waiting, they're in a block state because it's dependent on that one. So these 4 are waiting for this one to complete. And then as soon as these 4 are completed, I've got my 20 user jobs that already are in the queue waiting. So, and this is to simulate how you have a workload that actually fills up my on-premise environment. I've got a backlog. So now what do I do? Typically, you don't have any resources, so your workload has to wait. But in this case, this is where we're saying how you can move this workload into the cloud. Now, I also mentioned that this communication is done by the on-demand data center connect, which is actually communicating bidirectionally, right? So it passes all the workload over and it communicates with on-demand data center. For example, if you have a job, and this typical with your schedulers, you set as we call it, a wall time. You'll notice the wall limit. Now, I don't want my job to be running over my wall time. So when we are busy deploying my nodes, put it into as we call it, a suspended state until that node becomes available. So it's just showing the bidirectional communication. And while I'm talking, you'll notice my 4 jobs have come in using my 16 cores, and now my scheduler is aware of cloud resources and is busy moving those over into that side. Maybe just one last comment over here is you'll notice it's important that you could see there was 2 clusters, right? It could be 10 clusters. It could be 10 clusters, each one from different providers, could also all be available to my on-premise scheduler. Now, right, so now you'll notice that queue was empty. I've got my workload coming in and they queued, right? So they're not going to run because remember my cluster is in a bursting state because my nodes weren't available. Now, if I look at this, as my workload come in, now I've got my compute nodes that were down. They are busy deploying. And we've got something called a burst cycle, which we check the queue. It depends on what you set it. By default, it's 60 seconds, but you can check it based on what you want. And whatever was in the queue will start up whatever resources is required, right? And you'll notice there's different amounts of cores in these, right? And it depends. If there were 5 jobs in the queue, and something else to mention as well is you'll notice that my jobs only require 1 node, 1 core. It could have been, by the way, all my jobs are here now. They've been passed over from on-premise into on-demand data center. And as I mentioned, my job could actually be asking for maybe 5 cores and maybe 2 nodes. There's some applications like NPI that does inter-node communication, so it shares that workload between 2 nodes. And if it happens that I maybe only had 10 jobs, then it will only start up what's required. It would have started up the 8 plus the 4, and you can use part of as well. So it means that if there's 4 jobs, it only requires 4 cores. It will use, for example, this 1 node, and the rest of the 4 that will remain available for more workload that's actually coming in. So that's now we've got this process, and you'll notice these states here on the left-hand side. Initially, they were down, and then now we are busy deploying them. Now, as soon as they are deployed, and you can imagine it takes 3 to 5 minutes potentially, they will be moved into available state. And then as soon as they're available, they're going to a busy state, taking care of my workload. And depending on how long my jobs run, mine is set for 5 minutes. Then as soon as my workload is taken care of, my nodes become available again. Now, we've got something called an idle purge, which is how long should I keep my compute node up and running? Maybe there's more workload coming in. Maybe I want to keep it 10 minutes. I want to keep it an hour up. Mine is set to 2 minutes, but by default is 10 minutes. And then if there's no more workload, we'll take it into an offline state. The reason for offline is in case, again, if there's more workload coming in, we take them back from offline into available state. If there's still no more workload, then we destroy them again and they go down. So that's where the whole process is completely automated. Now, just going through some of these areas I mentioned in the slides. First of all, you have to have a credential, right? So over here, I've got multiple credentials defined. It's a very straightforward process. Remember I mentioned multi-cloud orchestration. You can select any provider from here. I select Oracle, I give it a name, and I can upload my credential file from my provider, or I can actually type it in here and save it.
Now, the next step is to do that stack, the image build, right? So you can actually, okay, so let's select one, I give it a name, and this is where I require my credential that I've been, that I saved in the previous step. And remember, this is important, this prefix over here, this is what my image is going to be called within Oracle in this case. And that's what my cluster is going to use because I've generated my image. And I have to give it a head node size. You'll notice there's a certain amount in here that I've got available. And by the way, this list is, we don't populate it fully with all available resources, but you can imagine some providers have got thousands, right? So we give you the option to add what is required based on your credentials that you can deploy. For example, if you put in one in there that is not, you're not authorized to, it will fail. It will not allow you to do it. It won't do it. So you have to choose a head node in the build stage, and it only gets used while it's built, 20-30 minutes maximum, and then we discard it. So then it gets destroyed. Of course, for example, Oracle is broken down different data centers. We've got to specify an availability zone and a sub-network. And in this stage is where you can add your application. We call it server provisioner, node provisioner. We typically suggest using it this way. So you can add your application with the stack build, then your application gets, let's call it installed within your stack build, within the image. And it gets saved with that image on your provider, and you can keep on using it. So then your stack build is done. Then the next step is actually creating a cluster, right? So again, you choose your provider, and again, you'll notice I'm sure you've seen already, it's very simple, straightforward, easy to use. You give it a name, let's just call it something, operating system, and this is the prefix of my image. I choose my credential, I choose a head node size, and then we've got two options in here. We use Talk, which is ours from Moab, or you can use Slurm as a resource manager, so you can run Slurm workload onto ODC as well. And then you choose your region, right? Which data center you're going to run in. I'm choosing a availability zone, and then we've got extra options in here if you want to change them. So you can make your head node and compute nodes storage sizes bigger. And this is the idle purge I spoke about. Default 10 minutes. How long should I keep my node up and when my workload is done? And then we start destroying that. And again, this is my prefix for my head node as well as my compute node. And we mentioned, I mean, Anoop also spoke about the different file systems. So by default, we've got NFS, BGFS already available because it's in our image, in our stack build. But you could use another file system as per what you require. And then you can choose your bursting option, minimum, maximum. You can do that even after you've deployed. And over here, we add our different nodes, right? So over here, I've got some bare metals. Let's add some in here. I can add more different type. So I can build up my cluster. And remember, it's not deployed yet, right? There's a GPU. Let me add another 5 of that. And you'll notice, you'll see a little figure here on the top. Now, as I added these and that one, my head node, you'll notice that goes up. And this is just an estimate. It's not exact. We know customers have discounts and so forth. It just gives you an idea before this cluster is actually deployed, what you potentially would be paying for this cluster if I deploy it. So I'm just going to go ahead and save it. I'm not going to deploy it, but just to show you that it's saved. And it's straightforward. You just click over here and you say deploy. And it goes ahead and it deploys it. Then that cluster is deployed, is available, and you can switch on your bursting. You'll notice the bursting is on in this case. As I mentioned, you can also run your workload directly from here, from, as we call it, pure cloud. I'm currently running workload from my on-premise, from Moab, but you can set up your own jobs over here, right? So it's a question of giving a name, say how many nodes, how many cores. You can add your script in here. You can add data files, and you save it, and you can actually go ahead and submit it. Here's an example of, people sometimes talk about this. This is a specific application we've also included in our stack. It's called Splice AI. They wanted to keep their input data on-premise and run their workload in the cloud, but then have access to it. So I set it up for them that by means of a VPN connection, they connect back to a shared NFS on-premise. it gets mounted, it gets used, and then I also write to that same file system, my output data, and then I dismount it and I disconnect my VPN connection. As simple as that. Very straightforward. No matter where your data is residing, maybe you want to keep your data in the cloud. Absolutely. Even between service providers for that matter. And it's a question of, there's a little suitcase here, you select your job, and you select the cluster that you want to run it on against. And this will determine how many, if my job, say, for example, 1 node, 4 cores, if my cluster doesn't have that, it won't list it over here, so I cannot run it against that. So I choose my cluster and I can hit submit, and it runs. So that's just a quick example of even running your workload directly from on one data center. So before, okay, let's have a look at the file manager very briefly. Now, file manager is we keep certain data, let's call it the standard out of jobs, and you'll notice my jobs are currently running because they're in use. So you'll notice the Moab name here that came from on-premise currently is being written to, so that's why it's in use, so I cannot view it until it's done. But if you look a little bit further down, I would have some in here that were completed already. Here's some that I completed 2 days back. Simple, straightforward. You click over here and you can have the standard out over here. Now, this is just the standard output that my job completed successfully. The output or the actual data that you generate from these jobs, you can write to your file system. And again, this is written back to my on-premise. Remember, I mentioned bi-directional communication. A few other areas, you'll notice the instances prices. Now, we pull this from the service providers. So I've got my list that I've defined in this environment. I've got my instance types, the different regions, and the cost for each one of these. Now, remember, this is an estimate. We know you've got potential discounts. And that's why we can actually use this information if we look at some of our accounts where we actually have information. We keep all this information, right? So I'm going to go back a little bit here in the history just to generate some input and output. It'll take a few seconds to pull it from the database. Now, what does this actually, we've got all this information. So even though you destroy a cluster, we have that data saved. Now, this is my user. This is some of my colleagues. And I can go and have a look at that specific user which ran certain workload between this period and that period. You can see it's over 1,579 jobs. And it gives my job start time, provider, cluster, the actual node, how many cores, and what was the runtime. Now, this is how we can actually generate a potential estimate for costs. All right, so let's just have a quick look at my cluster as it's running, and then I want to show you 1 or 2 other areas as Anoop calls it a persona, meaning different people have got different accesses and rights and don't need necessarily to have more than admin rights. So let's have a look at my queue. You'll see that's all completed. Now they're all available. So my workload has been taken care of. And that's where I remember I mentioned the process. We would have gone to busy, available, and now after my idle purge runs out, it will start destroying these nodes. One area that I want to briefly show you as well here is, and this is important in the sense of, let's first look at my different users. In other words, if you look at users that we create, now there may be admin users. Now this, what I've been showing and doing, would be an administrator. They would be the person setting it up and managing it, but they don't do anything with it. But then you would have a user that doesn't have an admin right. So they'll just be a user, and they don't have full rights. They can log in, they can run workload on the cluster, and they can set up jobs to run it on, on ORT itself. So that's one persona. Another one is if I, as a user, as I mentioned, I can do, as we call it, error collaborator. So as a administrator, I can share that with certain other groups or users within the environment, right? So here's some of my colleagues. I can say I want to share my cluster, that one, with a user. Now, when that user logs in, he's got his own login. He sees the cluster. He can run workload against it, but he cannot, change it, destroy it, or anything like that. So that's how we set up these different personas, different usages. You've got, for example, a scientist. He doesn't really care about all this. setting it up, but the administrator will do that. It's all set up, and your scientist will actually go ahead and run workload either from on-premise, as I've shown you, or directly from in here by using a job submit. Now, just briefly, a few more points over here. I just want to make sure that we cover everything for you guys. As I mentioned, the queue is done. You'll notice that, remember, just now it was available. Now it's moved into an offline state. And, my burst cycle is, set to a certain 60 seconds, and then we'll move it into destroying. So it's this different process that we follow, and it's all automated. I didn't need to do anything. And if we briefly look at my on-premise environment, there you'll notice it just started destroying. You'll see that. So now we're busy destroying those. They're actually being brought down, and you don't have to worry about that. And you'll notice my workload over here is also completed. I've got my 4 jobs that I'm running on-premise still, told it to run for 1 hour, and that's what's left over here. Now, I think those were the most key areas. I think at this stage, I do want to, one extra area. Now, this is more from you'll notice the name, Moa Viewpoint. It is actually my on-premise command line interface that's actually shown as a user interface, right? As the ODC side, this is my viewpoint environment. You'll notice these are my nodes that actually showed up on the command line. I can see what is still being used over here. Over here, I can just have a look at my workload. And you can actually run workload from here directly using the Moa Viewpoint interface. And there's additional functionality within this environment. This is more connected, I want to call, to my my scheduling environment, just as a thing that's maybe important to know about. All right, everybody, I think I'm going to finish off. Thank you very much.